Hello everybody, welcome into another lesson. So today we are going to do the binomial theorem, and this will be part one of a two-part lesson. So the binomial theorem here is given for if you have a binomial to any power, so x plus y to the n power. So up till now we've only done expanding binomials up to the second degree. Well, now with the binomial theorem, we can go to any degree. So the n is the degree of the binomial, of course, to which you're expanding. Then you have your two terms. To find a term of a binomial, any particular term, it's going to be to start with the coefficient. You'll have the combination of n things r at a time. So n is the degree, r is the term you're on. You'll take that combination times your first term of your binomial to the n minus r power times the second term of your binomial to the r power. So all that will give you the term that you seek for the binomial. Something to keep in mind about binomials is that it always has n plus 1 terms. So whatever your degree is, you add 1 to the degree, that's how many terms you have. So if this were to the first degree, obviously you're just going to get back x plus y. If we raise this to the second power, you would get x squared plus 2xy plus y squared. That would give you 3 terms. So if this were to the third degree, you'd have 4 terms. To the 10th degree, you'd have 11 terms, so on. Now, the first term of a binomial with this formula is actually always where r equals 0, because the formulas are written for r plus 1. So if you want to find the 6th term, you subtract 1 from that, and you're going to make your r equal to 5. So let's do some examples here of this. Now, in today's lesson, we're only going to find coefficients of a particular term or find an actual particular term. We're not going to expand these today. But in the next lesson, however, we will expand binomials. And I'll show you an easier way than really fully using the whole formula. But let's see. So here's our goal. We're going to be given a binomial here. So let's say I give you x plus 3, that quantity. We're going to raise it to the 12th power. We'll raise that to the 12th power. Find the x to the 4th coefficient. So first we're going to start out, we're just going to find the coefficient. So let's find the coefficient on the x to the 4th term. Well, your n is 12 because that's the degree that you're raising this binomial to. Now, your first term is x, so your x term is always to the n minus r. So in this case, n minus r, so r is 4. No, r is not 4, sorry. N minus r equals 4, since it's on the first term, the x term. Well, in this case, that would be 12 minus r equals 4, which would give you that r equals 8. So r would equal 8. Now we have enough to proceed to find the coefficient. So to find the coefficient, take the combination of n things r at a time. So n is 12. We determine that r is 8. So it'll be the combination of 12 things, 8 at a time, of your first term, which is the n minus r. So that would be your x to the 4th, which would really then give you 3 to the 8th power, since it's times your second term to the r power. So now we go ahead and we do this. Let's do the combination of 12 things 8 at a time. So that's going to equal 12 factorial all over that quantity of 12 minus 8 factorial times 8 factorial. So this will be 12 factorial divided by 4 factorial times 8 factorial. So we can simplify this more. We'll have 12 times 11 times 10 times 9 times 8 factorial all over 8 factorial. Then expand out your 4 factorial. This will be times 4 times 3 times 2 times 1. Well, your 8 factorials will cancel. 4 and 3 will both go into 12 and cancel out. 2 goes into 10 5 times. So what you're left with is 11 times 5 times 9, which should give you the value of that combination. Let's go ahead and find that answer here. You get 495. So the combination of 12 things 8 at a time is going to be 495. So this would turn into 495 times that x to the 4th times whatever 3 to the 8th is. Now what the heck is 3 to the 8th? 6,561. So if I take that times 495, I'll have my coefficient. So I end up getting a coefficient of 3,247,695. So that would be my coefficient on the x to the 4th term, 3,247,695. And I got more of these. All right, let's say this time I have x minus 2y. That quantity is being raised to the 10th power. They want you to find the coefficient on the x to the 8th, y to the 2nd term. So find the coefficient on the x to the 8th, y to the 2nd term. All right, well, our r is definitely 2. Because the 2nd term is raised to the r power, so r is 2. Your n is 10 because that's the power that this binomial is raised to. So we have it pretty easy here as far as knowing what n and r are right off the bat. So this is going to be to find the coefficient, the combination of 10 things 2 at a time times your x to the n minus r power, which was 8. They already gave it to you. X to the 8th power times your 2nd term of negative 2y raised to the 2nd power. So, and if you add the 2 powers here, the 8 and the 2, you should get the 10th power. So for both terms, if you add the 2 powers, you should get the power of the binomial that you're raising it to. So let's do the combination of 10 things 2 at a time. That's going to equal 10 factorial all over the quantity of 10 minus 2 factorial. Why am I doing that? That don't make sense. Times your 2 factorial. So this will simplify into 10 factorial all over 8 factorial times 2 factorial, which is going to break down into 10 times 9 times 8 factorial all over 8 factorial. Now break down your 2 factorial. That'll be times 2 times 1. Well, your 8 factorials are gone. 2 goes into 10 5 times, so literally you just have 5 times 9. So that's going to be 45. So you get 45. So this would turn into 45. X to the 8th is just that. X to the 8th times that negative 2y squared. That would be positive. Negative 2y to the second is positive 4y squared. So now just take 45 times 4, you'll have 180. So the coefficient on the x to the 8th y squared term is going to be 180. A couple more coefficients, and then we will go on to finding whole terms. All right. Good one. Alright, so we are given the quantity of x squared plus y raised to the 10th power. Find the x to the 8th y to the 6th term. Well, it's definitely clear that our r is 6, right? The n is 10, which, if that helps, that's the degree it's raised to, okay? Now, if x is to the 8th, we have to figure out x squared times what equals x to the 8th. X squared times what equals x to the 8th? Well, that'd be to the 4th, right? If I take x squared, raise it to the 4th power, I'll get x to the 8th. So really, you're going to have 4 and 6. So that means n minus r in this case equals 4, because 10 minus 6 is 4, and that would be always what is on your first term of the binomials to the n minus r power. So to find the coefficient, you'll take n things, which is 10, r at a time in this case, which is 6. So 10 things, 6 at a time, that combination, times your x squared raised to the n minus r power, which is 4, times your second term, which is y, raised to the r power, which is 6. And if you take that 4 and 6, you should get the 10th power. Okay. Well, all we're going to have to do now, because inside the parentheses for the variables, your coefficients are 1. So that's going to make your life a lot easier. All we have to do is just figure out a simple combination. So that combination of 10 things, 6 at a time, would equal 10 factorial all over the quantity of 10 minus 6 factorial times 6 factorial. So that's going to simplify into 10 factorial all over 4 factorial times 6 factorial. So this would become 10 times 9 times 8 times 7 times 6 factorial. We can stop at 6 factorial divided by the 6 factorial. Now let's expand 4 factorial. That'd be times 4 times 3 times 2 times 1. Well, your 6 factorials will cancel out. 4 and 2 both go into 8. Those are gone. 3 goes into 9 3 times. So this is going to turn into 10 times 3 times 7, which would be 210. So this would literally become 210 x to the 8th, y to the 6th, meaning your coefficient is going to be 210. So the coefficient on the x to the 8th, y to the 6th term would be 210. One more like this, then we'll find whole terms. We'll see what that looks like. All right. We are given z squared minus 1 raised to the 12th power. Z squared minus 1 raised to the 12th power. Find the z to the 6th coefficient. Z to the 6th, well, you have a z squared inside your parentheses, so that means we're going to have to figure out z squared to what power equals z to the 6th. Well, if I took the z squared, raised it to the 3rd power, I would end up getting the 6th. So my first term is the z squared, meaning my n minus r equals 3. Well, for sure, my n is 12, because the power of this binomial was raised to the 12th power. So this means 12 minus r equals 3, meaning that r equals 9. So r would actually be 9 in this case. All right. Now, we can go ahead and find that coefficient. So it's the coefficient of n things, it's the combination of n things r at a time, so this would be 12 things 9 at a time, times that z squared raised to the n minus r power, which is 3, then times your second term of negative 1 raised to the r power, which would be 9. So that's what you're looking at here. So let's find the combination of 12 things 9 at a time. Well, that's going to, of course, equal 12 factorial all over the quantity of 12 minus 9 factorial times 9 factorial. So this will turn into 12 factorial all over 3 factorial times 9 factorial. So this could simplify into 12 times 11 times 10 times 9 factorial all over 9 factorial. Now break down your 3 factorial. This would be times 3 times 2 and times 1. Well, the 9 factorials cancel out. 3 times 2 is 6. That'll go into 12 twice. So what you're really left with here is 2 times 11 times 10, which would end up giving you 220. So the combination of 12 things 9 at a time is 220. So this would turn into 220 z squared to the 3rd. That'd be z to the 6th. But don't forget that negative 1 to the 9th, which would be negative 1. So your coefficient would be negative 220. Since you multiplied by that negative 1, you get a coefficient of negative 220 for the z to the 6th term. All right. So shifting gears, we're now going to find whole terms. So that we do slightly differently than just finding a coefficient. So let's say we have the quantity of x plus 8 raised to the 10th power. So we have x plus 8, that quantity raised to the 10th power. And they want us to find the 4th term. We are going to find the 4th term of this particular binomial to the 10th power. So remember earlier when I said that your r is always 1 less than the term you seek. So 4 minus 1 is 3. So my r is actually going to be 3 my n is 10 for the fact that that's the power that you raise the binomial to. Now we can go ahead about finding these terms. So it's always the combination of n things r at a time, so this will be the combination of 10 things 3 at a time times the quantity of your first term, which is x, raised to the n minus r power, so that'd be 10 minus 3, that'd be 7, times your second term, which is 8, raised to the r power, which would be to the third power. And again, if you add these two powers, 7 and 3, you should get a power of 10. So that's how you know you're on the right track. All right, so let's go ahead and explore this combination of 10 things 3 at a time. So that's going to be equal to 10 factorial all over the quantity of 10 minus 3 factorial times 3 factorial. So this would give you 10 factorial all over 7 factorial times 3 factorial, which we'll break down further. You'll have 10 times 9 times 8 times 7 factorial all over that 7 factorial times, break down your 3 factorial. So this will be times 3 times 2 times 1. Well, your 7 factorials will cancel out. 3 goes into 9 3 times, 2 goes into 8 4 times. So the combination part will turn into 10 times 3 times 4, which would be 120. So the combination is 120. So this will start turning into 120. Now you have x to the 7th, which will literally just be x to the 7th, times whatever 8 to the 3rd is. Let's figure out what the heck 8 to the 3rd power is. That's 512. So now if you just multiply these three things, you have your fourth term. So take that times 120. So it's going to be 61,440 x to the 7th for your fourth term. So the fourth term of this binomial to the 10th power is 61,440 x to the 7th. And I got 3 more examples like this too. Alright, so what do we got this time? We have the quantity of 3x minus 2y to the 9th power. So 3x minus 2y to the 9th. Whoops, I'm looking at the wrong level. Hold on. I'm looking at exercises we just did. Hold on a minute. Alright, much better. X minus 5 to the 6th power. We're going to find the 7th term. Alright, so we got the quantity of x minus 5 raised to the 6th power. We're going to find the 7th term. Well, remember how I always said there's n plus 1 terms for a binomial raised to a power? Well, the power n is 6, so that means there are 7 terms. We're actually finding the last term. So that means your n is 6. Now, your r is always 1 less than the term number you're seeking. So 7 minus 1 is 6. So your r is also going to be 6 in this case. So now to find the term, you're going to take the combination of 6 things, 6 at a time, of the quantity of your first term, x, raised to the n minus r power, so 6 minus 6 is 0, times your second term, which would be negative 5, raised to the r power, which is 6. So let's figure out your combination here. So the combination of 6 things, 6 at a time, is going to equal 6 factorial all over the quantity of 6 minus 6 factorial times 6 factorial. So this would simplify into 6 factorial all over 0 factorial times 6 factorial. Well, the 6 factorials cancel out, 0 factorial is 1, so the combination is 1. Literally. So you would get 1 times what is x to the 0? That's just 1, right? So you actually have another 1. You just got to take -5 to the 6th now. That's all we got to do. So you're actually going to get a constant answer. It's going to be 15,625. So your 7th term would just be 15,625. You'll get a constant term for that. I got 2 more, then we're done with the lesson. All right. So we have the quantity of 10x minus 3y raised to the 12th power. We are seeking to find the 9th term. So we are going to find the 9th term of this binomial raised to the 12th power. Whoops, this should be 10x, not just 10, excuse me. I missed the x. That'll be 10x minus 3y raised to the 12th power, okay? Well, remember, your r is always 1 less than the term you're seeking, so 9 minus 1 is actually 8. Your n is the power that you raised the binomial to, so your n equals 12. Now that we have that information, we can proceed. So you start with a combination of n things, r at a time, so that'll be the combination of 12 things, 8 at a time, times your first term, which in this case is 10x, raised to the n minus r power. 12 minus 8 is 4. And then times your second term, which is -3y, raised to the r power, which is 8. And if you take that 4 and 8, you get the 12th power. So that's how you can know if you're on the right track or not. All right, let's investigate this combination here first. So the combination of 12 things, 8 at a time, what's that going to equal? Well, that's 12 factorial all over the quantity of 12 minus 8 factorial times 8 factorial. So this will turn into 12 factorial all over 4 factorial times 8 factorial. Okay, well, 12 factorial will break down into 12 times 11 times 10 times 9 times 8 factorial all over that 8 factorial times breaking down 4 factorial. So that'll be times 4 times 3 times 2 times 1. Well, your 8 factorials are gone. On top of that, 4 and 3 both go into 12. And then 2 goes into 10 5 times. So you end up with 11 times 5 times 9. So let's see, 11 times 5 times 9 is 495. So that combination of 12 things, 8 at a time, equals 495. So this will turn into 495 times that 10x to the 4th. Well, what's 10 to the 4th power? That's going to be 10,000. And then you'll just have x to the 4th. Now we got to figure out that -3y to the 8th. So let's take that -3y to the 8th. So start with that negative 3 to the 8th itself. That's going to be 6,561. And then you just have a y to the 8th. So now you just multiply all this together and, well, you'll have your 9th term. So this is about to be a lot of fun. We're about to get a really huge number. Now times another 495. Wow, so you get 32,476,950,000. X to the 4th, y to the 8th. So the 9th term of this binomial is 32,476,000,000. Oh, dang it. I knew I forgot the 950,000 part. 950,000 x to the 4th, y to the 8th. So yes, that is a really big number, and you will sometimes have that. And I got one more, then we're done with the lesson. Alright, so we have the quantity of 7x plus 2y raised to the 15th power. We're going to find the 8th term. So you have the binomial 7x plus 2y raised to the 15th power. They want you to find the 8th term. So again, your r is always one less than the term you're trying to seek. So 8 minus 1 is 7. So r equals 7. N is going to be 15 since this is raised to the 15th power. Now we have enough information to proceed. So this is going to be the combination of 15 things, 7 at a time, times your first term, which is 7x raised to the n minus r power. So 15 minus 7 is going to be 8, times your second term of 2y raised to the r power, which would be 7. And if you add the 8 and 7 together, you get 15. So that's how you can know you're on the right track. Okay, let's look at this combination first. So the combination of 15 things, 7 at a time, is going to be equal to 15 factorial all over the quantity of 15 minus 7 factorial times 7 factorial, which would break down into 15 factorial all over 8 factorial times 7 factorial. So this is going to be real fun. We'll have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8. Well, actually, we could stop there at 8 factorial. We're going to have a lot of canceling. Over 8 factorial, then break down your 7 factorial. So this will be times 7 times 6 times 5 times 4 times 3 times 2 times 1. Alright, well, your 8 factorials will cancel for sure. Now, 7 and 2 both go into 14, so those are gone. 3 and 5 both go into 15. Alright, 6 goes into, let's see, wow, this is a hot mess. Well, yeah, 6 will definitely go into 12 twice. If you take 10 times 2, you got 20, which would become just 5, which would get rid of the 4. Okay. So this really breaks down into 13 times 5 times 11 times 9. So let's figure out what that quantity is. That's going to be 6,435. So the combination of 15 things, 7 at a time, is 6,435. So this will become 6,435 times, now take that 7x, that quantity, to the 8th power. So let's figure out what 7 to the 8th power is. Wow. 5,764,801. Of course, you have your x to the 8th times your 2y raised to the 7th, which would be 128y to the 7th. Now just do all the multiplication. You're going to have a really hideous term. Oh boy. Ready for this? 4,351,351,287,680 x to the 8th y to the 7th. So there is the 8th term of this binomial. 4,748,351,287,680 x to the 8th y to the 7th. So today we've seen part 1 of the binomial theorem, which was just simply finding coefficients of a particular term or finding a particular term of the binomial. Which makes you think, oh my gosh, so if I were to do the whole thing, I'm going to have to apply this to every term. Technically, yes. However, there is a much easier way to do it, which that's going to be the topic of next lesson when we do the binomial theorem part 2. We're going to expand terms. We're going to expand the binomial, but 1, it won't be this high a power. Number 2, there'll be a lot simpler stuff inside. And number 3, there's a much better way than doing that. So that's it for this lesson. I will see you all in the next lesson. Have a great night. Thank you.